In truth, performance always matters. And it's always a little bit better when code runs accurately, just a little bit faster. But it's important to understand that, especially when it comes to Salesforce existing as a multi-tenant or shared server environment, code will not always run at precise speeds. From a programmer's perspective, CPU speed is non-deterministic. When it comes to the laws of physics, maybe that's a different story. But when it comes to executing code, a lot of factors are at play when it comes to instructions running on the CPU. Things like multiple instructions from multiple programs executing simultaneously, the amount of power to the CPU chip itself, the clock speed of the CPU, and how long it takes to retrieve items from memory. Memory retrieval is a big cause of variability, in fact, because depending on which memory block data is located in for a given run of instructions, that can influence how fast data can be retrieved. And some of that is a bit randomized from run to run. Overall, the best we can do as programmers is know approximately how fast code executes on a CPU. Probability story yields a tighter and tighter truth across averages over time. In other words, we don't know that a given piece of code will be completed within, say, 5 milliseconds one time versus 7 milliseconds another time. But we can eventually figure out that the code will complete on average within a certain number of milliseconds. And from averages, or from statistical truths, we can form solid conclusions about the performance characteristics of code. We know, based somewhat on relativism, whether something is taking an unusually long period of time. Some Apex will always run faster, of course, as some instructions simply take less time and are less computationally expensive than others. And there are times when that is always true, no matter the variability. Other times, that variability is of significant importance to understanding the fine details of the performance profile. Fortunately, code is very accurate, and we should always be able to be sure that for the concrete questions we ask in logic, it returns very precise answers each and every time the code runs to answer those questions. But again, how reliable is the speed? Lower level details still matter at the end of the day. There are some fundamental truths about the computational cost of algorithms, and those truths will remain. For example, there's always a cost of initialization, and we know that if we avoid initializing, then we at least avoid that cost, somewhat variable as it might be at a very small timescale. Apex itself will not overall get much faster if we have done all we can on our side as programmers to optimize our own instructions. There's some parts of the language and of the Apex runtime that remain mysteries to those who don't work for Salesforce. Unless Salesforce upgrades their own internals for how fast Apex runs, sometimes it's only going to be so fast. And there are times when Salesforce can't optimize the language runtime any further anyway. I suppose my point to all of this is, don't assume that code performs at a certain scale. Always measure. And then after some time has passed, maybe after Salesforce has changed a few things over the years, you might want to measure yet again. Things can change because you're not necessarily controlling everything about how Apex works. On the point of initialization, take a look at this. Let's say that I have a list of account records that gets initialized from this method call. In a typical for loop, I might initialize an integer at 0 and say that this loop should run while that integer is less than accounts.size. Well, accounts.size as a method call has a cost. Salesforce wrote what happens on a size method call. So they'd have to say what exactly happens when you make this call. But it's been discovered that making that call has a performance cost. What you can do instead is store the result of the size method call into an integer variable, which then gets set as another variable inside the loop. In this way, no reinitialization happens anyway. Only a comparison on whether the integer I is less than the account size integer variable. No initialization, no additional cost. This is something that takes intricate investigation to discover, and there are probably other little nuggets of value hidden away in Apex like this as well. This particular concept I found from the work of Paul Battison in a blog post he made regarding faster Apex loops. Since Battison did some initial digging, other experiments were done by Stephen Harrod, Andy Mahood, and Andrew Fawcett. You can find the URL to their original work in the course examples. In the upcoming demo clip, I'll show you some real results from utilizing this technique to avoid reinitialization, and you'll see it makes a surprisingly dramatic difference in CPU time. Before we get there, let's take a few moments to talk about the pros and cons of managed packages in the next clip.